Walaikum Assalam. How are you?
I'm good, sir. How are you?
Good, doing well. Acha, so these are the three parts that I asked you to do it. Were you able to do them?
Yeah, I did the first two. I can understand the third.
Okay, so let's go over them. Mm. So the question was to sketch these functions, logarithmic functions. So I'm going to find the y-intercept first. So y-intercept is going to be by taking x as 0. So y-intercept is going to come out as ln 4. X-intercept के लिए you're going to take y0.
Okay.
So e to the power of 0 is equal to 2x plus 4. E to the power of 0 is 1. So x is going to come out as minus 3 upon 2. Now you're going to give it a quick sketch. So would you agree that this value should always be greater than 0? So 2x plus 4
Yeah.
must be greater than 0. So x must be greater than minus 2. So at
Okay.
minus 2, I'm going to have a asymptote. And the x-intercept comes out to be minus 1.5, which is this value. And how will be the graph look like? The graph is going to look like something like this. Agreed? So this is minus 1.5, and this value is going to be ln 4.
Okay.
Okay?
Yeah.
Now, for the next part, the y-intercept is going to be 2 ln 2, and 2 ln 2 is same as ln 4, right?
Yeah.
Because this power of 2 is going to go up and this is going to make 4. X-intercept is going to be, so 0 divided by 2 is 0, e to the power of 0 is going to be 1. So x is going to come out as 1 minus 2 is minus 1 minus half.
Okay.
And the range of value of x for which this function is going to be defined is 2x plus 2 greater than 0. So this value must be greater than 0. So,
Sir, I'm a bit confused when solving it. How did you get one on the left side?
okay. So the idea is that 0 divided by 2 is going to be 0, right? Now this is your log equation. If I want to find the value of x, I'll have to convert it into an exponential equation. Ln is always to the base e. So e raised to the power of 0 is going to be 2x plus 2. E raised to the power of 0 is 1. So x is going to come out as 1 minus 2 is minus 1 minus 1 upon 2. Now does that make sense? So for the value of x for which this is going to be defined is 2x plus 2 must be greater than 0. So x must be greater than minus 2 upon 2, that is minus 1.
Okay.
So your asymptote is going to be made on minus 1.
Okay.
So this is minus 1. Minus half is over here. The x-intercept is going to be minus half. And the y-intercept is going to be ln 4.
Okay.
Okay. Now for the third part,
Yeah.
y-intercept is going to be y equals to minus 3 ln minus 9. So for this, y-intercept is not going to be possible because you can't have ln of a negative number. So there is no y-intercept. No y-intercept. For x-intercept, I'm going to take x, y as 0. So 0 divided by minus 3 is 0. E to the power of 0 is 1. X is going to be 1 plus 9, that is 10. 10 upon 6, that is 5 over 3.
Okay.
Now 5 over 3 in decimal, just to give you an idea, is 1.67. Also, for which value of x is this function be defined? This is going to be defined for 6. This is going to be defined for
Yeah.
6x minus 9 must be greater than 0. So
Yeah.
x must be greater than 9 upon 6, which is
3 point.
3 upon 2. That is
Okay.
1.5. All right. Now, do you recall that if you have minus, let's say in an equation, when you have y equals to k ln x, and if k was negative, then your
Yeah.
function would be something like this, a decreasing function. Oh, sorry, something like this.
Yeah.
Remember? So the
Yeah.
graph would be something like this. That's why it doesn't have a y-intercept.
Okay.
So x must be greater than 1.5. So my asymptote is going to be made on 1.5. The x-intercept is 1.67. 1.67 is going to be over here. So it is going to be the reflection in the x-axis. Okay?
Okay.
This is for positive ln(x). It is going to be now reflected, so that's why the downward shape. 1.67, which is 5667, which is 5 upon 3.
Okay.
Okay. Should we move on?
Yes.
Now, we are going to look at the concept on the graph, the inverse of log and exponential equation.
Okay.
The inverse of log, logarithmic, and exponential functions. So let's consider one example. You need to find the inverse of each function and state its domain. The first function that we are going to look at is f of x equals to 2e to the power of minus 4x plus 3. And this function has a natural domain of, this is defined for all real values.
Okay.
Now you tell me, is it an exponential function or a logarithmic function?
Exponential.
Exponential function. Do you remember the steps of converting a function into its inverse? The first step was to replace f of x with y.
Yeah.
And then we are going to try to make x the subject.
Yeah.
So y minus 3 is going to be equal to 2e to the power of minus 4x. Okay,
Yeah.
so y minus 3 upon 2 is going to be equal to e raised to the power of minus 4x. So I can rewrite this as e raised to the power of minus 4x equals to y minus 3 upon 2. Then I'm going to take ln on both sides.
Okay.
Then what is going to happen? What is going to be the next step?
So then it's gonna be equals to ln y minus 3 upon 2.
Yes. So minus 4x ln ln of e
Yeah.
is equals to ln y minus 3 over 2.
Yeah.
Ln e is 1.
Yeah.
So x is going to be equal to 1 upon minus 4, which is minus 1 upon 4 ln of y minus 3 upon 2.
Yeah.
Once you have made x the subject, you are going to replace x and y.
Y with X.
Yeah, you're going to interchange them. So y is going to be equal to minus 1 upon 4 ln x minus 3 over 2. So that's your, so in, since the function was in terms of f of x, you're going to write inverse function. You're going to replace y with f inverse of x, and the inverse function is going to be minus 1 upon 4 ln x minus 3 over 2, right?
Yeah.
So this is my inverse function. Now, do you notice that if your function was an exponential function, the inverse is the logarithmic function,
Okay. Yeah.
sahi? And that is going to be the case. If your function is a log function,
Yeah.
your inverse is going to be an exponential function.
Okay.
That's always true.
Okay.
So now you have done the graphs of exponential functions with me as well as logarithmic functions with me. So if I give you an equation, let's say if I give you an exponential equation and I ask you to sketch the graph, by looking at the equation you will be able to sketch the graph. But if you don't have the inverse function, still you can draw the inverse function of the graph just by the concept that the reflection of the function is going to be the reflection in the line y equals to.
Sir, can you say the last part again? I didn't get it.
Hmm. Okay, what I am trying to say is, okay, if I tell you that this is my exponential function,
Yeah.
okay, so without like having an equation, would you agree that the inverse function will always be the reflection
Yeah.
in the line y equals to x?
Yeah.
So if this is the graph of exponential function, do you agree that this is the graph for the log function?
Yeah.
So exponential function and log functions are inverse of each other.
Okay.
That was the thing. Now, in this question, you were also asked to state its domain. What do you think the domain of this function is going to be? Do you remember function और उसके inverse की logic?
Yes.
What is going to be the domain of this function? It's a log function, right?
Yeah.
So the log function can never be negative.
Yeah.
So log of bracket x minus 3 upon 2. So this term x minus 3 upon 2 must always be greater than.
0.
So x must be greater than.
Okay. 3 upon 2.
No, it's going to be 3. 2 times 0 is 0 plus
Yeah.
3.
Yeah.
So this is going to be the domain of the inverse function. Because the inverse function was a logarithmic function, this is how you're going to find the domain of the function.
Okay.
Let me know when you're done copying this.
Okay. Sir, I've copied it.
Okay. Let's look at another question. And that's the second part. You have to do exactly the same thing.
Okay.
F of x is equals to 3 ln 2x minus 4, and it is defined for x greater than 2. Now this time I have a log function as a function. I want to find the inverse function for it. What do you think
Okay.
so would you like to try this on your own first?
Yeah, I'll try it. Is it e to the power x upon 3 plus 4 upon 2?
Yeah, I think that's right. So y is equal to 3 ln 2x minus 4. This is going to be y upon 3. E raised to the power of y upon 3 is going to be 2x minus 4. So x is going to be y e to the power of y upon 3 plus 4 over 2. I'm going to interchange replace the x and y's, and f inverse function is going to be e raised to the power of x upon 3 upon 2 plus 4 upon 2 is going to be 2. That's my inverse function. Now, what is going to be the domain of this function? Is there any value for which this function is not going to be defined?
I can say it again.
Is there any value of x for which this function is not going to be defined?
It has to be greater than 2, right?
But that this domain was for this logarithmic function.
Yeah.
What about this exponential function? For this function, x, there is no restriction because it is going exponential function satisfy all values of x.
Okay.
So x belongs to real values. This function is going to hold true for all real values.
Okay.
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 Okay. Now in let's try another question. F of x is equal to e to the power of 2x plus 1, and it is defined for all real values. Part A says state the range of f of x. Part B says find f inverse of x. Part C is state the domain of f inverse of x and find f inverse f of x.
Okay.
Okay, so we are going to
Yeah.
look at these questions step by step. First thing first, what is the range of f? Now you will only be able to find the range of this function, this exponential function, if you visualize how the graph would look like.
Is it greater than 1?
Yes. So f of x is going to be greater than 1. How did you come to know that it was greater than 1?
I checked the graphs in which the point of like intercept was 1.
Okay, but did you right now did you just redraw the graph for or did you refer to your notes?
I refer to the notes for e
Acha.
to the power 2x.
Hmm. But now let's say if you did not have refer to your notes, so this is how I would have thought. E to the power of 2x is going to look something like this, okay? And this would pass through 1, and the entire graph of e to the power of 2x would be above 0. So for just e to the power of 2x, my range is going to be f of x greater than 0 because the entire graph is going to lie above the x-axis. But as soon as I add 1 to it, the entire graph is going to shift 1 unit up, right?
Yeah.
So this is going to shift 1 unit up, and instead of passing through 1, now it's going to pass through 2, and 1 is going to become your asymptote. That's why we are going to say that the entire graph lie above 1. So range is going to be f of x greater than 1.
Okay.
Make sense?
Yeah.
Okay. What about part B?
Oh, the additional part.
Yeah.
Is it ln bracket x minus 1?
Okay. So this is going to be y equals to e to the power of 2x plus 1, y minus 1 equals to e to the power of 2x. Now you're going to take ln on both sides. 2x ln e is going to be 1. This is going to come out as ln y minus 1. X is going to be ln y minus 1 over 2. And inverse function is going to be ln x minus 1 over 2. Is that what you are getting?
Yeah.
Okay. So this was part B. Part C says state the domain of f inverse. This is your f inverse. What do you think the domain of f inverse is going to be?
So would it be greater than 1?
Yes. Part C, it is going to be x greater than 1. That's going to be domain
Okay.
of f inverse of x. For
Uh,
part D, I need to now what would you call this function f inverse f of x?
was it composite function?
It's a composite function. The function f of x now is now being inserted in inverse of x. So let's go for it. F inverse के function में you are going to insert f of x. So
Okay.
f inverse function was ln x. Okay.
Yeah.
So in place of x, I'm going to plug in f of x. That is e to the power of 2x plus 1. Then there was minus 1 inside the function
Yeah.
divided by 2. So only at this place of x I have plugged in f of x.
Okay.
So if I simplify this now, plus 1 minus 1 got simplified.
Hmm.
Ln e to the power of 2x over 2. 2x can be come over here, 2x. Ln e is going to be 1. 2 cancelled out. So the answer comes out to be x. Okay.
Okay.
Okay, I think we are done with the chapter.
Okay.
Now we are going to look at some review exercises.
Okay.
So let's say, do you remember the change of base rule?
Yeah, I remember.
So there's a question on that. By changing the base of log to the base 2a of 4, you need to express log 2a of 4 times 1 plus log a of 2 as a single logarithm to base a. By changing the base of log 2a4, express the product of this as a single logarithm to the base a. Yeah. Did you say something?
No, so I was asking if you had written something.
Yeah, I did write it. Oh, is the screen frozen?
Yeah. Okay.
Okay, now you may be able to.
Yeah, no,
So try this.
Sir, is it log 8 upon a to the base 2a?
I don't know. Let's find out. So let's start with the working. Is the screen now visible, right?
Yeah, sir.
So I'm gonna change log 2a of 4, ठीक है, and convert it to log of a, log to the base a. So I'm going to take log to the base a of 4 divided by log to the base a of 2a. Now, if you remember the product rule, this
Yeah.
can be this is a product of 2 times a. So it can be simplified as log of base a of 2 plus log of base a of a.
Yeah.
So this is gonna give me log to the base a of 4 divided by log a of a is 1, log plus log a of 2. Now I
Okay.
need to multiply this because this can be represented in this form. So now I'm going to replace this log 2a4 with the expression that I found. Instead of writing log 2a4, I'm going to write log a of 4 divided by 1 plus log a of 2 times 1 plus log a of 2. Now, if you closely observe, the denominators are same. The denominator and this numerator is same. So I can cancel out 1 plus log 2, log to the base a of 2. So the final answer is just going to be log to the base a of 4. Fine?
Yeah.
Okay. Okay, so this was part A, and part B is hence solve the equation 5 to the power of 2x plus 1. Okay, I'm going to go step by step over here. Do you remember substitution?
Yeah.
So the substitution is given to us in this question, that is, take y equals to 5 raised to the power of x,
Yeah.
and substituting instead of 5 to the power of x with y, you need to show that this equation
Yeah.
can be written in this form. So this is an equation in terms of y. You need to replace 5 to the power of x in this equation and reduce it to the equation in y. Would you like to try this on your own first?
Yeah, I'll try.
Okay.
Is the first part 5y square minus 7y plus 2?
Okay. So this is how I would have done it. 5 to the power of 2x into 5 to the power of 1 minus
Yeah.
5 to the power of x into 5 to the power of 1 plus 2 equals to 2 times 5 to the power of x. So if I now replace this, I'm going to get, for 5 to the power of 2x, I'm going to get y square, right?
Yeah.
So this is going to be 5y square minus 5y plus 2 equals to 2y. If I simplify this, I'm going to get 5y square minus 7y plus 2 equals to 0. Hence, this is going to be, so yeah, I have shown it. So the value of A is 5, B is minus 7. A is 5 and B is minus 7.
Yeah.
Now they are saying, hence solve the equation. So if I, instead of solving this equation, I can solve this equation,
Yeah.
right?
Yeah.
So, so I'm going to solve 5y square minus 7y plus 2 equals to 0. Can you get me the two values of y, please?
Yeah. It's 1 and 2 upon 5.
1 and 2 upon 5. So what was y equal to? Y was equals to 5 to the power of x.
Yeah.
So 5 to the power of x equals to 2 upon 5. Now, what value of x will give you 1?
5 to the power 0.
So therefore, x is 0 from here. And for the second part, you have to take, either you can take lg to the base 10 on both sides or ln on both sides. That's up to you. So x is going to be lg 2 upon 5 divided by lg 5. What is this value coming out?
That's it's minus 0.56.
Minus 0.56.
Yeah.
Okay. So this was this question. Now let's try another question. Solve the following simultaneous equations. Log to the base 2 of x plus 3 equal to 2 plus log to the base 2 of y log to the base 2 of x plus y equals to 3. These are the two equations. I want you to solve them simultaneously.
So for y, is it 1.83 and minus 1.08?
So now I'm going to solve it and you can compare it. So that's my first equation, that's my second equation. And for the first equation, I'm going to bring all the log terms on one side. So log 2 of x plus 3 minus log 2 of y is going to be 2. Whenever two logs to the same bases are being subtracted, then I can represent this as a single log as x plus 3 over y. So once you have expressed this into a single log, you are going to convert it into an exponential equation. So x plus 3 over y is going to be 2 square.
Yeah.
So 4y equals to x plus 3.
Okay.
And from the second equation, it's going to be 2 to the power of 3 is equals to x plus y. So x plus y is equals to 8. That's my second equation. And x minus 4y is equals to minus 3. That's my first equation. Solve them simultaneously and get me the values of x and y. So I can just verify it from the calculator, whereas you can solve it, okay?
Okay.
Were you getting the same equations?
Getting slightly different.
Yeah, for x I'm getting 29 over 5, I don't know, and for y I'm getting 11 over 5. आप भी जरा चेक करके बताएं मुझे, is it coming out to be same? Is it same?
Yeah, it's coming the same.
Okay. Okay. Please solve this.
Is the first part ln x plus 2 upon 4?
First of all, you complete both parts and then I can solve it in a one go.
Oh, and for the second one, I'm getting 1.
All right, just give me a minute. I'm uploading some worksheet for you. So I'm gonna get back to you in 1 minute, okay?
Oh,
Okay, I've assigned a worksheet to you. Okay. Try to do as many questions till the next class
Okay.
if you get time. Otherwise, we are going to do it in the next class anyways. Now, function g and h are defined by these, and you need to find g inverse. So, g inverse for this is coming out to be ln x plus 2 over 4. Did you get the same?
Yeah, I got it.
Okay, for the second part, x is coming out to be 1.
Yeah.
All right. ठीक है. चलो ठीक है. So I have given you the worksheet. There are other questions. That's the summary of this chapter. It's a review question worksheet. You can look at it. Try to do as many questions as you can till tomorrow, and then from tomorrow onwards, I'm gonna do it. Do the same questions with you. Okay?
Okay.
Is there anything that you would like to ask me?
No, sir, understood.
Okay, and how soon are you gonna get your paper back? The question
Sir,
paper?
like, since the exams got postponed till Jan yesterday, so probably I think next week he should be done checking, maybe.
Okay, okay, all right. Chalo, see you. Bye bye. Take care.
Thank you, sir.
You're welcome.